is Chapter 3 of the NALMCO training course. This one for Certified Senior UVC Technician. Also a prerequisite for the Certified Management Professional in UVC technology. The last chapter was on lamps that are used for germicidal UV light applications. So this chapter will look at the luminaires that hold those lamps. Focus here is not on lamp type or luminaire type, but on application of luminaires for specific applications. So the goals for this chapter, Chapter 3, is for me to describe all parts of the luminaire so you can understand them. Describe also how the luminaire, its purpose is to shape the light pattern to something desired. To compare the luminaire with visible light luminaires, which all of us are familiar with in our homes of various kinds. And then we'll take a look at various applications of UV luminaires and hope you can understand the various applications. Again, understand UVC is potentially harmful. I emphasize potentially because we don't want them to be harmful. So luminaires are designed for both occupied and non-occupied spaces, and these differ obviously. The objective is that you will be able to describe various kinds of UV luminaires, how they work, and how they should be applied to a given application. So the first question is, what is a UV luminaire? And the answer is, it's the same thing as a light luminaire. So what we have basically is a housing that contains a light, a ballast or driver, and optical elements. So the first thing is a light. These three, or actually four if you count the housing. So the luminaire has a lamp. It's probably the most essential part. A lamp of various kinds, various shapes, various emission patterns. And pictured are a handheld low pressure mercury lamp lit in a wand, a Philips UVC to low pressure mercury, and an excimer light source. We spent a lot of time in Chapter 2 going through these various sources, and so again you can see how these are now applied in various luminaires. But the lamp has to be driven by a driver made for that lamp, and so for fluorescent lamps, the general terminology is to call it a ballast. For LEDs or more complicated devices, we call them drivers, but the basic idea is the same. They control the current and power of that lamp to something that is designed to do. Lamps by themselves need these control devices. Thirdly, a luminaire is basically contains optical elements which manipulate the light in a desired way. What is shown is a blowout of an upper room luminaire, where you can see kind of the blue part is a reflector. There's a lamp, a light blue lamp too, but the other light blue element shown, third element, is a reflector. So this reflector basically takes light from the lamp, which goes in every direction, and focuses it forward. And actually the tray on this is also an optical element, but it's more a shield. It performs a simple job of blocking light from going down. So in this case, the optical element is a reflector, but it can be a diffuser. It can be a refractor. And we can also put lenses or baffles in to either spread the light or focus the light as we choose. And of course, all these three elements are put in a box or a housing, and the housing then gives the fixed configuration for a given application. Picture are a baffled upper room luminaire. And so the light only comes out in a beam straight forward away from the blue that you see toward you in the picture. The other one is a LED luminaire, which has a single LED, and the point of the luminaire is to spread the light so it doesn't go straight down, but is reflected in a circle or a donut shape above 75 degrees to 90 degrees. So when mounted in the ceiling, this provides kind of a LED light above the heads of people. A reminder that when we talk about UVC, we're talking about radiation or emission from a lamp in the 200 to 280 nanometer wavelength region. And UVC was found a long time ago to be very effective in activating microorganisms, viruses, as well as bacteria and molds and other kinds of things. But UVC, germicidal UV, is harmful to human skin and eyes if a given dose is exceeded. So we want to design a system, obviously, that avoids harm. And this is done, but in the actual installation application, we also want to make sure that it is put in a place that it does as intended and not put in wrongly. So the major elements of germicidal UV, that is light in the UVC region, is to maximize the efficiency of the inactivation of microorganisms, and to do this in a safe way so that the radiant energy, which could be harmful to humans, does not it does not involve human contact. It is safe. We have applications. Let's start with unoccupied spaces, rooms. This is often used in medical establishment to disinfect a room after a patient leaves or between patients. The system provides a very high dose of germicidal ultraviolet and effectively disinfects the air, but in this case, the main purpose is to disinfect the surfaces in the room. Pictured is such a unit which has multiple 3-foot lamps, about a dozen of these in a circle, on a portable unit that can be put in and turned on. And so that the unit, when finished, disinfects the whole room. It is moved from place to place to make sure that it's in the room, but always done safely. And this is typically what is used to disinfect unoccupied spaces. Portable units are often done because these cannot be used in the presence of human beings. So they must be safely accounted for. The other application then is for occupied spaces. The last one was for an unoccupied space. And these divide into three categories. Upper room disinfection. This is a idea that the ultraviolet is put in the room, but it is put in the room above the heads of people. And the air is kind of circulates through the irradiated parts, and therefore the air is cleaned or disinfected as it circulates naturally through the room or with the help of a fan. Normally, low pressure mercury lamps emitting at 254 nanometers is the source used. However, LEDs have been designed to do this job as well. LEDs that emit in the 250 to 270 nanometer region. Whole room disinfection. So here we are talking about disinfecting the room with people present so that they actually encounter the radiation from the devices. So this kind of emission must then be kept below the emission safety limit for the reasonable amount of time. The reasonable amount of time is usually 8 hours, and an organization called ACGIH has published the maximum emission limits called threshold limit values, or TLVs, which can be used for a given wavelength. But because of their because the body can handle larger amounts of dose at 222 nanometers than at 254, significantly higher. These 222 nanometer excimer sources have become dominant use in whole room disinfection. There's also room air cleaners. Here the lamp is completely enclosed, but the room air cleaner can be portable, brought into a given room in a floor unit, but they can also be mounted on the walls or in the ceiling, complementing air ducts and other things, even lights in the ceiling. But the point is that there is no outside exposure of the germicidal ultraviolet. It is all contained within the box of the cleaner. So talking about then upper room application, and we see over on the right, the yellow circle, a device, upper room device having a low pressure mercury lamp in with a reflector, and in front of it are louvers that prevent the light to spread downwards or too much upward. So the light then comes in a beam, which is regulated so it doesn't go below 7 feet and can reach the ceiling, but also try not to hit the ceiling too much. Mostly they want a beam of light above the heads of people. So that is the major application for upper room is the low pressure mercury lamp in some kind of configuration like this. There are really two kinds. One, which is an open unit, does not have the louvers or the things that cause the beam of light. The one on the left then can shine light upwards to irradiate the whole upper room space. This is particularly useful for places with large or tall ceilings, and where they are much more efficient because the louvers do block a lot of the light. So this is used in that situation. However, you don't want too much light hitting the ceiling because the ceiling may reflect the UV down into the place where people are. So you need to be careful. And therefore, the unit on the right is designed to so that it throws a beam of light above the heads of people, just like the one on the left, but it doesn't allow much radiation upwards either to prevent it from hitting the ceiling. So most of the light is below the ceiling. Next slide. This shows a very large fixture. On the right, you see the fixture mounted as an upper room application. And then the picture on the left shows multiple LEDs. And actually, there are 3 layers of these, only 2 are pictured. Each LED then emits light, which is focused outward. And so it also, between the optics of the LEDs, it spreads the light horizontally, but not vertically. So it again behaves a little bit like the louvered low pressure lamp. It puts a beam of light, but because most of the optical elements control the light beam, you don't need louvers, which make the system very inefficient. So LEDs are more efficient in terms of getting its light out into the space, but LEDs are much more inefficient in themselves in low pressure mercury. So in a sense, it's a trade-off in the amount of light that you get from an LED fixture versus a louvered low pressure mercury lamp. Whole room. Here, the emission must be kept below emission safety limits, again, for a reasonable amount of time. Here we see an example in the yellow circle where a excimer lamp is put on a stand. Most of the radiation is above the heads of the people, and it's sort of a beam, which is about 30 to 40 degrees wide. So when you stand underneath it, there is no irradiation close at hand. But as you go further away, there is more. But then the larger distance makes for less irradiance. So in this case, people are exposed, but minimally by putting it up above. They are also mounted in ceilings, directing the light down. And so these are valuable ways of getting this done. On the excimer lamps, there are 2 examples. One is the one on the right is an example without a diffuser, and the one on the left has a diffuser in place. You see that it's the light underneath it are the same, but you can't see them because the light is diffused. So the advantage of the diffuser is it takes the light that is mostly directed straight downwards and spreads it outward in a cosine distribution. That is a light that falls off as the cosine of the angle between vertical and horizontal. The advantage then is that you can get the same radiation that you have from a light, but much less direct radiation downward, so that people standing under the lamp, it takes much longer to reach the dose limit from the same source with the diffuser than it does to one without a diffuser. Room air cleaners, we mentioned. They can be permanently installed. Typically, when they do, they use low pressure mercury lamps for disinfection. Although there are smaller units coming in with LEDs in them, which are much easier to fit in small units. Most room air cleaners also incorporate a particulate filter called the HEPA filter to clean the air of nano and micron-sized particles, as well as the volatile organic compounds. For that, you need an active carbon filter, which can be incorporated in the room air cleaner, but often is not. And so one that involves both both a filter, HEPA filter, a carbon filter, and a UV lamp provide the ultimate room air cleaning capability, because it removes the pathogens that are in the room, viruses, for example, COVID. It cleans the air of both the volatile organic compounds and small particulates. However, the price obviously goes up as you add these elements. There's a portable floor unit shown. It comes in various sizes, made for small, medium, and large rooms. And so it can easily be bought from any Amazon or any other many distributors. So, but in these units are cost sensitive, and most of the ones in the open market do not have ultraviolet lamp even, or a charcoal filter. They usually have a HEPA filter, or a filter to clean the air. And they are very effective in doing so. The difficulty is that the volume of air that needs to go through it is very small compared to the air circulating in a room for upper room, or even direct irradiation of a room. You irradiate all the areas. Here, only a small fraction of treated air has to be then put back in the room. So the exchange of the room air using room cleaners is usually very, very small. Fractions of a room change in and out. There are other applications that we in this course will not talk about much. Water is disinfected to provide safe drinking water. The other, for example, New York City, I understand, it treats all the drinking water with ultraviolet lamps, both mostly lower, medium, high pressure lamps to get this disinfection. And so utilities, but they can install small units for other kinds of purposes. And again, the lamps are put directly in the water, or depending on the water temperature, it can be put in a sleeve around so that the water doesn't contact the surface directly and cool, for example, a low pressure lamp. And even on a high pressure lamp, the difficulty is the surface temperature of the quartz is so high it would boil the water. So you don't want to have direct contact with the water, but it can be done for low pressure mercury. Food disinfection is another application. Typically medium pressure mercury lamps are used here, but low pressure mercury lamps can also be used depending on the way the food disinfection, usually on chain-driven belts, are put through a chamber. And it's done in pre-packaging to provide safe food. So the conclusion from the Luminaire section, a luminaire consists of a housing that contains one or more lamps. It contains a ballast driver for the lamp, and it has optics to steer the light and limit the light from going to the places you don't want, and optimize the light in the place you do want. But therefore, a luminaire is designed for a given application. Luminaires for unoccupied rooms can allow light to come out all over, and therefore you need much less optics with it. For occupied rooms, you have three kinds of spaces: upper room, cold room air cleaners we talked about. To ensure the UVC effectiveness and safety, GUV luminaires need to be assessed and certified both before and after installation. Thank you.